Hello students, today my topic of the lecture is sinusoidal oscillators. So oscillators is basically are the waveform generators. These are generated waveforms of different desired frequencies and constant amplitude, and the desired frequencies are obtained by the varying of the circuit parameters. If output waveform is sinusoidal, then it is called the sinusoidal oscillators, and other than sinusoidal waveforms like square wave, triangular wave, sawtooth wave, then it is called the non-sinusoidal oscillators. So according to generation of the output waveforms, we of different frequencies up to suppose gigahertz we have generated by the use of different type of oscillator circuits. In oscillator circuits, basically it has the different applications like transmitting, broadcasting, space applications, frequency meter, time meter, and different type of applications are present of the sinusoidal oscillators. And the classification of these oscillators are broadly basically classified upon the frequency range over which they are used. Second, according to design principle, and third one according to the nature of the waveforms. So when we talk about the frequency, then according to that, if the audio frequency we have used, that is 20 hertz to 20 kilohertz. In case of radio frequency, 20 hertz to 30 megahertz. In case of high frequency, that is 1.5 megahertz to 30 megahertz. Very high frequency, 30 megahertz to 300 megahertz. Ultra high frequency, 300 megahertz to 3 gigahertz. Micro oscillators, that is more than 3 gigahertz. And we talk about the design principle. Then we use the feedback oscillators, means some active device we have generated the output, which is the fraction of the output we have giving via the some feedback element to the input. So totally we have generated in terms of feedback oscillation in this same phase of the output with respect to input. Suppose we have generated the negative resistance oscillators, means we have used the active device which have inherently used the negative resistance characteristics because they have generated its own oscillations. And third one is nature of waveform, means we will talk just about that sinusoidal nature, and other than sinusoidal, that is called relaxation like triangular wave, sawtooth wave, this type of oscillators. This is basic the feedback, where we use that generally use the feedback oscillators. So in this case, output is feedback to the input. Output fraction, that is V naught. Suppose Vi is our input, then the output is V naught is equal to A times of Vi, which is feedback via some feedback element towards the input, that beta into V naught. So if output is feedback with the input in same phase, then we use the positive feedback, and in this case we have used the sinusoidal oscillators, generally use the positive feedback circuits. So principle of operation, in which I will just explain here the thing that the output source here we have for initiation we have required some input source. Suppose at this point we have giving the input, and according to that, after the passing of the amplifier, A into X form it is generated the output. Suppose via some feedback fraction beta we have giving in the input in same phase, then output is our A B into X. Suppose in this case, if we have total loop gain, means A into beta nearly equal to 1, then it is same as the previous input which you have required in the circuit. So according to that, suppose in this case this basically voltages generated are the basically the noise voltages which are generally produced in the circuits, like voltages, noise voltages via the random motion of the electrons in the resistors and electronic active circuits. So according to that, suppose this generally normal voltage we have required in terms of noise voltage, and we have not required any input towards the giving as a source as the input. So according to that, it is generally follow the Barkhausen criteria for sustained oscillations, in which I have just here suppose that signal providing in the input, then output, and output again via some feedback element we have given the input. So in this requirement, basically two standards are follows. Total loop gain A into beta is nearly equal to 1, and total phase shift according to closed loop, that is alpha plus beta equal to 0 degree or 360 degree. So it is the Barkhausen criteria for the sustained oscillation. So next, that is the requirement that is initial voltage via which we have generated the sinusoidal waveforms via the noise voltages. And first requirement is that A beta is generally greater than 1 for increasing the oscillations, and after that A beta equal to 1 for saturation condition, means sustained of the oscillations. So I have explained the next circuit, that is called the Hartley oscillator. So Hartley oscillator, in this oscillator basically we have provide the resistive biasing, means voltage divider biasing in terms of resistance R1 and R2. Here RFC, that denotes the radio frequency choke coil. The work of this choke coil is said that it provide the direct current to the collector of the transistor, but it is just avoid the high frequency AC currents. And here we will use the two capacitors in below of the transistor emitter terminal, that is the bypass capacitor, and input side and output side CC, that is called the coupling capacitors, via which we have introduced the input and output towards the input and output mode. And below this, here denotes the tank circuit, which is the combination of L1 and L2 and parallel with capacitor C2. So that is our tank circuit via which we have generated the sustained oscillations or frequency of oscillations. So in the working condition of this, basically when we provide the voltage from the VCC supply, from this the capacitor is charged towards the VCC, and via the L1 L2 capacitors are discharges. So in the tank circuit, oscillations are generated as a desired frequency, and via the voltage produced across the L1, which you have generated the base of the input of emitter of the base emitter junction of the transistor, and it is amplified, and the amplified output from collector terminal, which is provided again in the base tuned circuit for the losses in the circuits, and we will take the output across the induction coil L2. So in this case basically total 180 degree phase shift is generated by the L1 and L2, and again remaining 180 degree phase shift by the common emitter of the basically use the active device, that is our transistor. So in this case we have totally provided the 360 degree of the output. So for the working condition, I have just the calculation for the desired frequency. For this we have used the equation. First I have converted this circuit into this H parameter equivalent circuit of the transistor low frequency circuit model. In this case HIE, HREVC and HFEIV and HOE. But in this case I have directly converted the current source into voltage source, that is equal to HFEI1 upon HOE, and this is series resistance in terms of 1 upon HOE. So in this circuit I have converted, and when we taking the loop conditions I1, I2 and I3, according to that I have generated this determinant matrix, and in this matrix when we solve by this current I1, I2 equal I3 equal to 0, we have just take the real and imaginary parts. When we take the imaginary part and real equal to 0, then I have calculated the omega, means frequency, that is 1 upon under root L, but the f is equal to 1 upon 2 pi under root L into C equivalent 1 upon 2 pi L 1 upon L 1 upon L 1 upon under root LC, means f is equal to 1 upon 2 pi under root L equivalent C. L equivalent is denote the L1 plus L2 plus 2m, where m is denoted by the mutual induction between the coils of L1 and N2. Next, for minimum condition of sustained oscillations, that is generally I have when real part is equal to 0 of the determinant matrix, then we would take the del L2 plus m upon L1 plus m, that is basically the denoted by this matrix. As the same condition when we take the Colpit oscillators, so same condition, same diagram is there, but change is that we have used the two capacitors parallel with L equivalent circuit. So same, all the things are same, but here we have generate the total 180-degree phase shift via the capacitor C1 and C2 and provide base of the transistor, and collector output is generally fed in the circuit. So in this case, total 180-degree which are generated by the 180-degree by the capacitors C1 and C2, and remaining 180 generated by the base emitter junction, total emitter junction, base emitter junction of the transistor. So we have totally generated the total output 360-degree. In this case, when we solve the circuit, same condition of previous, that I1, I2, I3 and convert it into frequency H parameter circuit. Then I have calculated the way different three equations by which you have calculated the determinant matrix and take the real and imaginary part nearly equal to 0. From that I have convert 1 upon 2 pi and root L C equivalent, where C equivalent is our capacitors which are generally in series, that is total combination C1 C2 upon C1 plus C2. And for minimum oscillations we have generally take the formula when real part equal to 0, that is C1 upon C2 plus del C1 by C2, where del is equal to HOE minus HRE HFE. Thank you.